The last thing that I want to talk about here in this section is the end behavior of polynomials. And let me write out a general polynomial. That way we can use some of it to help define what's going to go in this table. So we have f of x is equal to a sub n x to the n. And we have plus a sub n minus 1 x to the n minus 1, and so on. And this will go all the way down until we get to just our constant term. So we have a2 x squared plus a1 x plus a sub 0. Okay, so all of these a's here, okay, so maybe I'll just write a sub i's. These are real numbers. This notation here just means that all these a sub i's are elements of the real numbers. They can be any real number. Okay. Now, n has to be a positive integer. Okay. N has to be a positive integer for this to be a polynomial. Okay. All right. Now, the next thing is we're going to fill this in based on a couple things. One is we're going to base it on this highest power here. So if that n is even or odd, we'll change things. So I'm going to say n even for this column and n odd here. Okay. And then down here, there's another thing that we're concerned with, and this is called the leading coefficient, a sub n. Okay. So if a sub n is greater than 0, or if it's less than 0, it will matter. And this table that I'm about to fill out here, you probably won't forget it after this if you're familiar with your even and odd degreed polynomials. Okay. Let's start off with the case where n is even and this number in front of x to the n is positive. Okay. So what I want you to actually think about is just x squared. Okay. Just x squared. Well, it ends up that the end behavior of x squared looks the same as it does for every even degreed polynomial with the positive leading coefficient. And if n is even, but then that leading coefficient is negative, we know that that negative is going to flip our graph across the x-axis, right? It's going to cause a reflection. And so the end behavior, again, is going to look just like minus x squared. And then if we go over here to odd, I want you to think about x cubed. So if the leading coefficient was positive and n was odd, well, we don't know what's going to happen in the middle, but we know that the end behavior will match that of x cubed. Okay? Again, no matter what polynomial, as long as n is odd and the leading coefficient is positive. And then the very last one here. So if n is odd and the leading coefficient is negative, it's just going to flip this around. So we'll have something that looks like this. Okay. And so these dots in the middle just mean that lots of things could be happening there, right? If n is a really high number, our graphs could have lots of humps in them. But all we care about right now is we're really looking at the limit as x goes to positive or negative infinity. And so we're going to use these rules now to try and do two limits. Here's our first one. So here we have this 99 here. So we have that n, well, I probably don't want to write that up there. N is odd, and a sub n is negative. Okay. So if we go up here, and by the way, I should mention one more thing. This is as x approaches positive infinity. Okay. But we want to go look in our table. Well, if n is odd and the leading coefficient is negative, what's that look like? Okay. Well, that was this one that's here in the bottom right. Okay. So you can see here we go. You can see that as x approaches positive infinity, the y value is decreasing without bound. Okay. So this limit here is minus infinity. Okay. And let's try one more. Okay. This time we have a positive coefficient, so the n here and the a sub n are the opposites. The a sub n is positive and n is even. And what that tells me is that this is going to have the same n behavior as x squared. And I know that as x goes to infinity, x squared also goes to infinity.